Class, here we are again. We're looking at the tangent function. This is the next of the three trig functions that we're going to focus on in this class. A good reminder is that you guys should have memorized the simple concept of SOHCAHTOA. So as we look at this, remember the idea is SOHCAHTOA, C-S-O-H-C-A-H-T-O-A, SOHCAHTOA. And hopefully you remember what that means. It means that if you have a right triangle, and you are looking at this, then the sine is going to be equal to the opposite over the hypotenuse. The cosine is going to be the adjacent over the hypotenuse, and the tangent is going to be the opposite over the adjacent. So this is the only way you can spell SOHCAHTOA, S-O-H-C-A-H-T-O-A. That really is a nice mnemonic device in order to help you out. Today we're going to focus on the tangent of theta being equal to the opposite over the adjacent. A lot of students say this is the easiest of the three of them to really work with. It's probably because of the amount of experience they have with both the sine and the cosine. I'm not going to really throw anything newer at you. Additionally, with the opposite and the adjacent, you really don't have to worry about the hypotenuse, and so sometimes you can get some easier numbers. Why don't you take a minute? Why don't you use your calculators and work at this out to 4 decimal places, just these numbers here at the bottom, and we'll try to get some answers here in a minute. The tangent of 21 degrees, hopefully you got 0.3839. For the tangent of 35 degrees, hopefully you got 0.7002. And for the tangent of 39, hopefully you got somewhere around 0.8098. Again, we're looking for precision with this, so hopefully you're able to get these numbers without too much trouble. Again, we'll be moving on. Okay, example number 2, we're going to be looking for the tangent of r. We're also going to be looking for the tangent of s. It does say to write each as a fraction, so we'll write as a fraction, and then also a decimal. Let me remind you that this fraction right here, this fraction should be a fully simplified fraction, and we'll work with that just a little bit today to make sure that you have a fully simplified fraction. When we're working with these numbers, today we're just going to be able to kind of just about ignore the hypotenuse, because when we look at r, if we're working with a tangent, all we really need to do is focus on this being our opposite side over here, and this side down here being our adjacent side right here. So when we work with the tangent, we'll talk about the tangent of angle R. That's going to be equal to the opposite side, which is 18, over the adjacent side, which is 80. You can simplify that fraction simply to 9/40ths. Okay. If we were to calculate this using our calculator, we should get 0.225. Okay. Then what we do is we go through and we actually switch the opposite. We actually switch the opposite and the adjacent around. So this side now becomes my opposite side, and this side over here becomes my adjacent side when we focus on angle S. Okay. So angle S over here, this is going to give us the tangent of S. The tangent of S is going to be equal to, this time our opposite side is 80, and that should be over 18. That simply reduces our fraction down to 9/40ths. I'm sorry, 4, I said that wrong. Let me just erase that really fast. That simplifies our fraction down to 40/9ths. Which is simply just a, if we look at this, this is just the reciprocal number over here. Okay, so those are reciprocals. So this makes this very easy when we just talk about this. After that, we'll just get our fraction. Unfortunately, it's a little bit harder to do. This is a kind of a weird number. It's 4.4444. Okay, so we're rounding to 4 places. I'd say that's 4 places after the decimal, so I'd say that's a pretty good number. For the tangent of j, we'll look down here. Again, we can ignore the 40. We're just going to focus on these. The tangent of j, let me just write this up here. The tangent of j is going to equal the opposite, which is 24, over the adjacent, which is 32. When you simplify that, that's 3/4, or that just gives us the decimal of 0.75. Someone asked me yesterday if you need to have a 0 there. I think it's a really good idea, because sometimes when you write your 0, if you don't write your 0, you sometimes lose that decimal place. So that's where we're at. Secondly, we'll look at the tangent of k. The tangent of k is just simply going to be the reciprocal of this, so 32 over 24, which simplifies down to 4/3, or as a decimal, this just gives us 1.3333. Okay. Lastly, we'll look at this other triangle over here. Again, I would just about ignore completely this whole hypotenuse because you really don't need it for these problems. I'm going to try to fit this all in, maybe down here. We'll start off here with the tangent of j. The tangent of j is going to equal 8/15. 8/15 as a decimal becomes 0.5333. Lastly, the tangent of k is just a reciprocal, so 15/8, which equals 1.875. I trust that you guys can use a calculator pretty easily. Some things that you'll notice, just to take note of, sometimes you're going to have numbers over 1. This is something kind of new. Sometimes they're decimals like this, but sometimes these numbers, just like this one right here, are actually greater than 1. Okay, so this is not a huge shocking thing. It's just we're going to be taking ratios, and sometimes our numbers, like right here, our number 15 is actually greater than 8. So when we take that ratio, well, that's obviously going to be over 1. Okay, moving on. It says find the tangent of A, find the tangent of B. Write your actual answers as fractions and as decimals as needed. This will be a good opportunity for you to pause and for you to work these problems out on your own. It's a good idea to just try these problems out as we go on. Welcome back. I'm going to actually write these out for you. This says the tangent of A, that should be 24 over 7. That should give you an answer of 3.4289. The tangent of B is going to equal 7/24, which just equals 0.2917. For this middle problem, we'll have the tangent of A. Tangent of A equals 35 over 12. 35/12 can actually be cannot be simplified, but we get 2.9167 as our answer. For the tangent of B, again, it's just going to be the reciprocal, so that's 12/35. So that should be 0.3429 as our answer. When we move back up to the third problem, we'll talk about the tangent of A being 48/20. 48/20, both those numbers are divisible by 4, so we'd have 12/5. 12/5. 12/5 equals 2.4 when we write it as a decimal. The tangent of B is going to be the reciprocal, so that's 20/48. Again, both those numbers are divisible by 4, so we'd get 5/12. 5/12 will equal 0.4167. Okay. So thanks for trying those. Hopefully you were successful with these problems. Let's move on. Let's look at the next set of examples. I think these are a little bit easier. Again, you're not solving for two things, you're just solving for one thing. In this case, you're solving for x. It says use a tangent ratio to find the value of each variable. Round to 4 decimal places for the trig value. Round to the nearest tenth, and that's what we're really going to focus on, is round to the nearest tenth for the length of the side. It does say if you want, you can use a triangle sum theorem to find the measurement of the missing angle. I'm going to ignore that right now. I don't think that's a really good idea for us to focus on. I do want us to focus on rounding to the nearest tenth, though. Something I noticed a lot of people did not do. So for this first one over here, we're going to look at this. We do have an adjacent side and we have an opposite side, so it's a big hint that we're going to be using the tangent function. So we'll just simply write this out. The tangent of 32 degrees is going to equal, well, what's it going to equal? It's going to equal 11 over x, our adjacent over our opposite over adjacent. When we cross multiply, we'd have x times the tangent of 32 degrees equals 11. And then we'll divide both sides by the tangent of 32, and we'll get x equals 11 over the tangent of 32 degrees. When we put that in our calculator, x equals 17.6. It's a good answer just to circle. That is what our answer turns out to be. What we're going to notice is that we're going to have some problems that start off with the x on the bottom in the denominator, and some that'll have an x in the top. And there's kind of two different ways to solve these. depending on where that x happens to be. In this case, the x, because it's the adjacent side, the x is on the bottom, which means that we actually have to do kind of two steps to multiply by the denominator here to get the x on this side, and then we divide both sides by the tangent of 32 to get our ratio. Let's look at what happens with, well, the next problem is going to be just about the same, but then it's going to switch when we get over to this third problem. So watch what we have in common with the second problem. Again, what we should notice is that we have an opposite side and we have an adjacent side, so it's a good hint to us that we'll be using tangent. So we'll say the tangent of 61 degrees is going to equal 22 over x. Again, that's going to be our opposite side over our adjacent. We'll multiply both sides by x, so that'll be x times the tangent of 61 degrees equals 22. We divide both sides by the tangent of 61, so x equals 22 divided by the tangent of 61 degrees. In our calculators, we'll simply type that in, and x should equal, round to the nearest tenth would be 12.2. For the third problem, we're going to notice something different. Again, what I was hinting at here was that notice over here our x was on the bottom, notice over here our x was on the bottom, and we had to kind of go through this same technique. We're going to have a different technique actually on this third triangle as we work this out. Again, based on where this degree is at, this is our opposite side, this is our adjacent side. So when we set this up, we'll just start off with the tangent of 56 equaling our opposite, which is x, over 13. Notice that the 13 is what's on the bottom here. The 13 is in the denominator. So all we'll have to do is multiply both sides by 13 in order to get our answer. So that's 13 times the tangent of 56 degrees. We can just simply put that in our calculator. X will equal 13 times the tangent of 56. That should be 19.3. We'll put a circle around that because that's our final answer. It's a much shorter process if our constant is in the denominator, as opposed to having to almost do 2 or 3 steps in order to get our answer. Okay. Let's take a look at just a couple more of these. As we look at these, we'll notice a couple of things here. That where the variable is, sometimes it's adjacent, sometimes it's the opposite, sometimes it's the adjacent. Whenever it's the adjacent, you have to do something specific. Whenever it's the opposite, you're going to have to do sort of the shorter method. That's why I focused on having more of these adjacent ones, because it's a little bit more work for us to show. Okay, so with this first one over here on the left, we'll start off saying, we always start off saying the tangent of 41 degrees. In this case, it'll be the opposite over the adjacent, so that would be 12 over x. You multiply both sides by x, so it'll be x equals x times the tangent of 41 equals 12. And let me clear this up just a little bit here. Let me start this over. The tangent of 41 degrees is going to equal 12 over x. After that, we're going to multiply both sides by x. So that would be x times the tangent of 41 equals 12. In that point, we're going to divide both sides by this tangent of 41. So x would equal 12 divided by the tangent of 41 degrees. We can put that in our calculator and we'll get 13.8 when we round to the nearest tenth. Sometimes I have little handwriting issues here, but it's okay. Over here we'll have the tangent of 27 degrees. Tangent of 27 degrees will equal, I don't know what's going on there. Let me try that again. The tangent of 21 degrees is going to equal, it's not 21 degrees. Let me try it one more time. We're going to get this. Maybe if I switch colors to something green, this will work out better. The tangent of 27 degrees is going to equal x over 15. That's your opposite over your adjacent. This time we'll multiply both sides by 15. We'll have 15 times the tangent of 27 degrees. We'll simply put this in our calculator. X will equal 7.6. Put a circle around it because it's done. Last problem over here. There's plenty of room to work it out. we'll just say that's the tangent of 58 degrees will equal 22 over x. Multiply both sides by x, we'll have the tangent of x times the tangent of 58 equals 22. Divide both sides by the tangent of 58, we'll have x equals 22 divided by the tangent of 58 degrees. Put it in our calculator, x will equal 13.7. Okay, 13.7 is a length. It's actually the length of our x value right here. It shouldn't be 13.7 degrees. Some people were actually writing that down, 13.7 degrees. I've not actually talked to you about how to find angle measurements. We might do that on later this week or another day. This is what we've been working on. I think it's a good idea for you to remember just kind of what different problems look like, how they work. And it's always a good idea to remember SOHCAHTOA. If you want to go home and refresh this and talk to your parents about your trigonometric ratios, I think this would be a good way for you to review, just to talk about what is SOHCAHTOA, what does it mean, what does it stand for, how might you set problems up. Wouldn't be a bad idea if you could also draw a picture like this over here to talk about what the opposite, the adjacent, and the hypotenuse mean. If you need any help with any of this homework, make sure to let me know. I will be more than willing to help you when I get a chance.